Hello? Hello? Okay. Whoopsie doodle. I had accidentally pressed the button on my thing. Okay. Now we should be back. So be a few things we'll talk about here today. Obviously, getting right back to the swing of things. All right, cool, cool. Um, yeah, so I had the makeup class on Friday for section 3.7. Yeah, so I mean, I know some of you have questions about that and stuff. We talked about arguments and whatnot on Friday. Uh, I just had like one person show up, but I still do the lesson anyway. So yeah, that's pretty much how that goes. So that'll I have to keep going regardless. Like I do apologize though about last uh last Wednesday. So I mean my computer was really in bad shape, and I mean really bad shape. So it was in a bad way. A lot of things got corrupted and stuff. So man. All right, we're going to start in a couple minutes. So, do you guys have questions though? While we wait. You guys let me know what you guys want to ask. No? Okay. Okay. All right. How was your weekend, guys, by the way? Meh. Meh. I know. It was okay. All right. That's fair. Yeah, it was okay. I had so much work to do though. I'm still not even caught up yet. So much to do, so little time. I just can't even catch up right now. So, well, I hope to be caught up by to the end of the day today, maybe? Hopefully. I try. Okay. Let's see. All right. Well, other people may or may not come in. I don't know. Again, it's during regular class time, so I'm just gonna go with what we got. All right. Alrighty, let's do this. All right. Okay, let's get started today. Welcome back to Monday. Hopefully, everybody had a meh weekend or a nice weekend. In any case, So again, I do to both of you and to anybody else who's watching here. Again, I do want to apologize in regards to last week. Obviously, the computer went kaputski, and yeah, a lot of sectors got corrupted, and things needed to be formatted and cleaned and repaired, and a whole lot of other things. But now the computer is running great. So now I have everything set and ready to go, and they even did the cabling for me, which was very nice of them to do. I asked, "Hey, can you do the cabling for me? Because I'm pretty bad at having a rat's nest here as cabling." So I was like, "Oh, okay." And he's like, "All right, cool, I'll do it for you." I'm like, "Yes, all right." So I was very happy about that. Hey, Julio, how are you, my friend? Yeah, apologies, Julio, about last week there. Well, I'm glad you're able to come back. Thank you for coming back. I really appreciate that. Um, so if you guys want to see what the new cabling kind of looks like here, here I'm just gonna take this guy off. This is the computer here, and as you can see, you can peep at this all you like. This is the new cabling. It's got the setup and everything here. I'll just move the monitor out of the way a little bit. So this is the thing. I got the fans up front here, all RGB and stuff like that. Wow, I can't do. Ugh! Hang on a second. It's hard to aim the camera at where I want to. So let me pan back a bit. So as you see here, this is the box. Here's the internals. Blah blah blah. Some meds. Um, yeah, so you can see that the cabling is a whole lot nicer than it used to be. It's not a rat's nest anymore. And I got the RGB on half. That's why it's not doesn't look like totally bright. But yeah, that's my setup right there. It runs very smooth, very nice. It's very good for what I want it to do. It's very good. So, all right, let's put that back on. Okay, there we go. So now you've seen the setup there about how I stream all the time. I have two monitors and stuff, and it works out okay, and things. Anyway, um, all right, now you guys get to see where I'm sitting from a little bit. There's a Predator monitor over here. So actually, I should probably show you that too. It's the Predator monitor. So yeah, it's got all this stuff. And my place is kind of a mess. So there you go. Yeah, man, I had to put in some money to get this, but it's not like a super like expensive setup. It's just like I got these new headphones. So I got the new the Cloud Alpha S gaming headset. It's like $150. Cloud ones are really good. I had to get a new one because my old clouds that lasted me like 9-10 years. Actually, the right side went out after that long, which was amazing. I mean, to last 9-10 years as headphones is quite a remarkable feat in itself. So I was really happy that even if it even if it crapped out, I was like, oh wow, you lasted a long time. That was really good for $100. I can't really lie. All right. In any case, now that you've seen the setup and everything, the Dawn is in the building. Is that so? I see how it is, Riverside. I have to pay my respects to the Dawn. All right. uh, all right. So let's go ahead and talk about something very important here. Now, last time, even though it was a makeup class, I did finish off section 3.7, which was the last section of chapter 3. Now, what that means is that there will be a test, okay, on section 1.1 and chapter 3. All right, so I have basically made up the shell of the test there online. I'll be posting it here later today. How you doing, man? It has been a while, my dude. It has been a while. How have you been? Uh, but yeah, we'll be doing a test. I have a test already kind of made up. It's like currently it's 60 questions, but I'm not gonna give you 60 questions. Obviously, I'm gonna pare that down. So I got a rough draft of the test, and then once I get that done, I'll be posting that. Now, uh, to give you a highlight here for the test, I will be posting a practice test. Oh no, goodness no! Oh no 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 no! No goodness no! Gosh, that would be terrible. uh, yeah, you can calm down there. I would never do that to you, Sam. I never do that to anybody. Holy moly. This test, because of the stuff last week. Good. I'm glad you're surviving, dude. That is good. That is good. What you been up to, by the way? So just to give you a heads up here, how's the test going to work? So it's going to be questions from every section. Um, there will be a time limit on it, but I'll give you like plenty of time, like like three, maybe 4 or 5 hours to finish. However, you get what you're gonna get is you're gonna get three. You're gonna get three retries. Okay. Um, yeah, you could go ahead and use notes. That's fine. You go so three retries. No, actually two. No, one retry. Yeah, just two tries. I'll just put two tries. That's what because you can use notes. So uh, two try. Three. Okay, fine. You convinced me. Three tries. Three tries on the test. Best score. Best score wins. Um. Practice test. Practice test will be just like the regular test. Yeah, if you convince me really like that, then I'm cool. So three tries on test, best score wins. Practice test will be just like the regular test. Same amount of questions, same type of questions and everything. So once I make up the practice test, I'll be posting that so you have a chance to kind of go through the questions. It'll have like the help me solve this sort of deal. It'll have like the guidance, and then you could try the real test without that stuff there, and then you can go ahead and give it a go. So you'll get three tries on that. Um, and the option here, just to let you know about how it's going to work here for the test, you will have what's called a save for later option. Okay, so save for later option here on my math lab works like this. You could basically, because it could be a long test and you may have other things to do, you got life and stuff to do. I said that's cool. You can save and exit out, but you cannot do the problems that you've already answered. So if you've already answered a problem, you can't go back and do it again if you log back in, say, the next day. And the amount of time that you have will be starting the clock from where you left off. So that's basically kind of where we're at there. Some questions are multiple choice and will be very quick. Some portions will be, hey, make me some truth tables. Some questions will be conceptual in nature. So, yeah, it's kind of a mix of a lot of things. Now, if I were to give like a paper-based test, I rarely, if ever, do multiple choice. I may give like a very little amount. Now, everything here is online, so of course, we're kind of limited by the questions that we're given here. Multiple choice, actually, surprisingly enough, is not the best choice for a math test, in all honesty. So, you know, will it tell you if you get the question wrong or right? For the practice test, it will, only after you submit it. So once you submit it, it will tell you that you're wrong or right after the fact. So that's why I put the little help on the practice test to like help me solve this, or textbook or whatever, show me an example. So that way you can be guided through if you need to, for those questions. So I put the practice test as literally a regular test. That way you get a feel about how it will do. You can take the practice test as many times as you want. So there's no limit. There's no time limit. There's no many amount of times that you have to take the practice test. It is exactly as it's intended to do, practice. So And literally, the test will be a literal copy of the practice test, just not the same stuff, like the same numbers or whatever. So when I mean practice test, I literally mean practice test. It's right there. You can't go wrong if I'm just telegraphing it to you, literally. Like literal telegraphs. I'm not sure how much easier I can make it, but I swear I'm gonna make it as easy as I can. You guys got any other questions? Nah, no problem, my dude. It's all good. It's how we take care of each other. So, okay. Remember to set aside some time to finish, though. So, it will take a little bit of time, that's for sure. So, I'm expecting I have 60 questions right now, preliminarily, but I expect to probably pare down 20 questions. So I should have probably this test here is going to be like 40 questions or so. So that should be fine. Because a lot of them are sort of multiple choice type problems, so they go by pretty quick. Okay, cool, cool. Yeah, so just make sure. So, one thing to keep in mind is when is this due, right? So, of course, I got to talk about when this is due because of the time, because of the last class there. Normally it'd be due this week, but of course, I'm not going to do that. Instead, I'm going to make this due on the, yeah, okay. So this is going to be due, and I'll send out an email in relation to this as well on Blackboard. So I'll make an announcement on there. So this is due on next Wednesday. Okay, so next Wednesday, I have to actually change that due date. So next Wednesday is when this test will be due. Okay, so plenty of time. You have a week and a half of which to finish. If there are any complaints, well, yeah, there shouldn't be any complaints. All right. Hopefully that makes it as simple as possible. Yeah. Woohoo. Okay. That works. Okay. uh, well, I don't have a lot of time between then. Well, I might have some time. So, probably after, not directly after the class is over, but maybe it's either going to be between 4 and 5 or it's going to be after 7 o'clock or so. So it just depends. It just depends. So that's kind of depends. But it will be tonight at the very least. So yeah, just to give you something to look forward to, I suppose. All right. Okay. Now that everybody is caught up and ready to go, woohoo! All right, now we can get into hopefully what will be a little bit more enjoyable than maybe the last chapter. Okay, so let's talk about this next chapter here. We're gonna skip all the way from chapter 3. We're gonna go all the way to chapter 7. That's the goal here. Now, what's chapter 7 here? Well, here's the nicest part. I think it's something that you'll all like very much. And so chapter 7 here talks all about algebra. Hey, I think algebra is a little bit easier to maybe manage compared to logic and truth tables. So I think a lot of people like the transition here because of the how used to it you are compared to a logic sort of deal. So which I totally get. Okay. In any case, let's go ahead and take a look here at section 7.1. Now, 7.1 talks about some of the basics here in regards to graphing and functions and whatnot. So let's at least talk about that. So what are graphs? What are functions? What are things that we have to do? Some of this is not really all that hard. So 7.1, graphing and functions. Okay, first of all, let's talk about graphing. I think most people know what graphing is. Again, with graphing, we have ordered pairs. Okay, so the ordered pairs here, as you know, always comes in the form of x comma y. All right, so we have an x coordinate, we have a y coordinate. So most people are pretty familiar with that. And if we go to the paint thing, you never find that thing. Oh, there it is. Yeah, as you can see, it is a pretty new setup here. So a lot of things are very different than old streams. Okay, but here we go. We're gonna, again, as you've seen a graph before, here's a line, here's another one. Remember that this is the x-axis over here. This is the y-axis up here. Okay, and if we were to do a point here, like let's say 5 comma minus 2, okay, we would go 5 would be the amount of units on the x-axis, minus 2 is the amount of units on the y-axis, 5 is the amount of x units to the right, so 1, 2, 3, 4, 5, and minus 2 would be 2 units down on the y-axis, so 1, 2, and there we go. There's our point, 5 comma minus 2. Or you have -1 comma -3. So you go 1 unit to the left and 3 units down. Hey, my goodness. Did you see that? Did you see that? Illuminati confirmed. All right. Now, if we really want to go all Illuminati here, let's see. Let's take one more point here. Let's say 2 comma 4. Okay. 1, 2, 3, 4, right? 2 comma 4. Yeah, yeah. See that? Totally confirmed. Now you don't have to connect the dots, but you'd be like this. So you put the little I here. Woo. Okay. Check it out. Exactly. All right. So now that you know how I exacerbate control over people, yes, I am a full-fledged member. I have one tattoo, and it's only of the Illuminati. Oh man. Holy cow. All right, maybe it's not the Illuminati, but I don't even have a tattoo. All right. All right, ignoring all that. Okay, so this is easy. This is just graphing stuff. Yay. Okay, it's great. It's a thing. Sure. No problem. Now, of course, other things that we have to do in here is like other things that we're doing in here is, of course, talking about functions. We're also talking about how to graph certain things. So, like for example, here, let's talk about equations. Okay, so equations here would be like y is equal to 3x plus 2. Okay, and you say, hey, I want to graph this in some form or fashion. All right, we can do that. You could do x squared. You could do a lot of other things. Now, the one thing that I guess I can point out regarding this is, let's say I wanted to do 3x. Let's change that up. 3x minus 2, because you get nicer numbers. All right. So let's say I decided to take this on and say, all right, I want to graph y is equal to 3x minus 2. Okay. Now, what's the key to graphing this type of equation? So let's talk about that. So the key here to graphing, is fairly simple, is to just make an XY chart. You just make an XY chart, and all we're going to do here is, if we go look at our XY chart here, we're just going to have X here on the left and Y here on the right. Okay, so boom, there we go. Got it. So all we're going to do is take some X values. We're going to just take any random X values, so long as it's easy to work with. We're going to plop it in for X, and then we're just going to see what we get out for Y. Simple enough. Okay? So let's take a look and see how that works. All right. Okay, so let's choose an easy number here to start with. What's an easy number to start with? Okay, 0 is a pretty easy number to start with. I agree. Okay, so if we plug in 0 into this function, what do we get? -2. Good. Nice. Okay, let's choose another number. What's another good number here? Let's just choose another number. Wow, Kulam, thank you for the Prime subscription, dude. That's really, really kind of you. 1, 2, okay, both of them are. I don't know if I deserve that, but thank you so much. That's really, really super kind of you, dude. Very kind. All right, let's try 1 and 2. So if we plug in 1 in here, what do we get? If you plug in 1 in for X, what do we get? All right, we get 1, right? So again, we get 3 times 1 minus 2, right? That's going to equal 1. I deserve it for drawing horses so well. Oh man, that's that drawing. Holy cow! That was the extent of my artistic side. I swear. Oh mercy! All right, that horse, man, that horse. Oh. Draws a horse? Oh no! I'm being asked again to draw a horse. Okay. This time I'm going to try a little harder. Okay. All right, we get 4 for that. That's true. You plug in 2, we get 4. That's absolutely correct. Do you guys want me to draw a horse again? It's not pretty. My art skills are second to none, and I mean really truly second to none, as in none. None should really be underneath me when it comes to drawing skills. Look, I'm being kicked out of art class in 6th grade, I should say. Yeah, that told me everything about my art skills. All right. In any case. All right. Okay, so here we have 3 points. We got 0 comma minus 2, 1 comma 1, and 2 comma 4. Oh my gosh. All right, so let's go ahead and draw this out. So we get 0 comma minus 2. That's going to be right here. 1 comma 1. That's right here. And finally 2 comma 4. 2, 3, 4. Which is right here. So that should give us a good enough template to, in this case, draw a line. So we're going to connect the dots here. This is okay. So we're going to extend that line out like so. And there we go. We have a graph for this particular equation. So we make an XY chart, plop in some numbers. There we go. We got it. Seems fair. Fair enough. All right. Not too bad. It doesn't smell. All right. All right. Questions about that? Can I show which part again, Julio, my friend? Oh, okay. So you can see here, right, Julio, you have 3 points. You have 0 comma minus 2, you have 1 comma 1, and you have 2 comma 4. So then I just kind of went around and I said, all right, if I have 0 comma minus 2, let me put that point on the graph. So that was kind of right here. So let me go back here for a second. Fortunately, the undo button is very helpful. Boop, boop, boop. All right. So then again, 0 comma minus 2 is right here. Okay. Then we have 1 comma 1, which is right here. And then we have 2 comma 4, which is right here. We play connect the dots here. Okay. And there we go. That's how we come up with that graph there, Julio. All right. So hopefully, yeah, no problem, my dude. It's all good. We're here to help, all right? Any other questions you guys got before we move to the next example? Or next problem, I should say. Nope. Okie dokes. All right. So next, let's talk about what's coming up next. All right, next we're going to talk about functions. Yay, functions. Now, first things first here. The one thing I want to talk about here first when it comes to function is notation. All right, so notation is a pretty big deal. All right, as we do see this notation quite often. So if I go to my new version of math type, where it doesn't look like I stink. Okay. Let's try this out. Okay, I'll get it later. All right. So the notation here specifically is going to be f of x. Now, literally, you could put in any letters that you want. You could put g of x, h of x. You can put s of y. Okay, if all letters are in terms of y, whatever. It doesn't really matter. But f of x is the most common notation for functions here. All right, so that is notation here. So what you'll see is, like, if we have up above, we have y is equal to 3x minus 2. Now, one thing that's important here, actually, I guess I need to say this right now, is, so let me make an important note here in relation to the notation. So this will actually be rather important. So let's do this. So let's put a note here. So one thing that's important to get to know about functions if it's like saying, well, how do I work with f of x or whatever, is basically saying this. F of x is the same thing as y, okay? F of x is the same exact thing as y. There is no difference between y and f of x. They are the same deal. So what does that mean in the grand scope of things? Well, if we assume that this is true, and it definitely is, then we say, all right, well, I could look at the first example here of y is equal to 3x minus 2. Okay, so that's how we wrote it the first time. But now I can rewrite it as f of x is equal to 3x minus 2. There you go. These are the same exact things, both of them. So there's no difference in the first one, and there's no difference in the second one. Absolutely the same. All right, questions about that so far? Hopefully that's pretty straightforward. Okay. Okay. Now, let's go ahead and talk about how to evaluate functions. So that's going to be our next step here. So evaluating functions is literally just like plugging in a number and then seeing what we get outside of that function. All right, and let's talk about a couple of examples. Sure. This time I'm going to put them up here, make it easier. Okay, actually, yeah, I'll put one note in regards to that. Okay, so I'm going to make up a function here. Okay, so I'll make up a function. So I'll just say f of x equals 2x squared minus 3x plus 1. Okay, so this is our function here of some variety. Okay, doesn't really matter, but boom, there it is. All right. Now let's say I wanted to do f of 2. So I asked you, okay, hey, can you tell me what f of 2 is? Okay, so what does this essentially mean? Well, this essentially means is anywhere we see an x in f of x, we're going to replace that with the number 2. So that's all we're doing here. We're going to replace that with the number 2. So basically, let's talk about one of the keys here. So anywhere we see x, we replace it with the number or expression and then evaluate. Okay, now let's talk about what's going on here in this case. So in this case here, and I'll be adding to that very important note part, we're going to take this 2 and we're going to replace it in for every x in f of x. So we're going to have 2 times 2 squared minus 3 times 2 plus 1. Okay, and so we get 2 times 2 squared, that's 8. And then we get minus 6 plus 1. So the answer to this is 3. So f of 2 is equal to 3. Okay, that's fine. Okay, any questions about that? That shouldn't be too tough, hopefully. Question mark, maybe. No? Okay. Now, here's one thing I do want to point out. Okay, this is really important. Okay, this is the big important note I'm actually going to put here. If there's one thing that's going to help you in algebra, besides one other thing that I'll mention here, it's whenever we're using functions, especially in algebra, and we're evaluating them or doing anything with them. The one thing that you should notice the way I wrote out the work for the problem. If you notice here, I put 2 in parentheses. Anywhere where we substitute a number or an expression, we should always put parentheses around what we substitute. So that's the important note here. This saves you a lot of pain and time. So again, always put parentheses around what you substitute. Now, the biggest reason why is because we can deal with positive or negative numbers, and that could easily change the sign. And if you bip bop boop in the calculator, one thing that's absolutely true is that -3 squared and with parentheses -3 squared are not the same thing. They are two different expressions that have two different answers. Okay? So if you try it in the calculator like you get -3 squared, you'll get -9. And that's true. But -3 with parentheses, that's +9. And that's true. So parentheses make a big, 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 big difference in evaluating these. So you say, hey, I'm going to use my calculator to figure this out. That's fine. Go ahead. But know the pitfall in doing so, without the parentheses. There's going to be a big one if you're not careful. So just need to take that a bit seriously there in that case. Let's take the same function here. Let's try another one. Let's do f of -4. So let's do f of -4. So what is f of -4 going to be? What's f of -4 going to be? Let's write it out. 2 times -4 squared minus 3 times -4 plus 1. Anybody got an answer for me? Yep. What's the answer to this? Ba-da-ba-da-ba-ba-ba. Good. That works. I'm happy with that. Any answer for me, guys? Hopefully we can figure this out. All right, so here we got -4 squared. So that's going to be 16. Minus 3 times -4 is plus 12. And we'll add 1 to that. 2 times 16 is 32. Plus 12 plus 1. So here we get 44 plus 1, which is 45. So there we go. We got it. Perfect. All right. Good stuff. Yep, 45 is the correct answer. Great. All right. Any questions about evaluating functions? Sure, I can absolutely do one more. Absolutely. Let's look at another function then. And yeah, I want to show off another function. I think that's a good idea, Julio. So let's look at another function and we'll try another one. Okay. Okay. So let's see here. Let's go with h of x is equal to -x squared minus 2x plus 5. Okay. So let's try a couple of numbers here. First, let's try h of 5. Let's try h of 5, just for whatever. Just making up numbers here. So say h of 5. Well, what's that? Well, plug in 5. So we're going to plug in 5. So again, I'm going to put parentheses around the 5, where I'm putting then that 5 in for x. I have minus 2 times 5, and then plus 5. Again, let's go over this here carefully. So if we have 5 squared, that's going to be 25. That negative that you see on the outside here is separate. So that's going to be minus 25 there. And then minus 10 minus 2 times 5, and plus 5. So minus 35 plus 5, so this is minus 30. Okay. Yeah, minus 30 is correct. That's right, Fernando. So again, just take it one step at a time, okay? You follow the order of operations. You're taking it one step at a time. You're going to get that down, slowly but surely. Let's look at one more here with this example. Let's try h of negative 3. So let's try h of negative 3. So h of negative 3, what's that going to be? Where did I get the 5? I just made this 5 up. I just kind of made it up. Like I just took the value of x being equal to 5. So all these problems here that you're going to see are just going to be random numbers thrown in for x. So if I go back to the book here for a second, let me go ahead and show this off to you. What page is that on? 422. So if you look at the examples here, you notice that all these problems here are have like random numbers and stuff. So just to point out, be like, oh, where'd you get that from? It's like, okay, it's right there. They just kind of give it to you and like, here you go. All right, cool. Been really thirsty lately. Okay. All right. So let's take a good look here at good look here at our other example. H of minus 3. Okay. So again, we're going to set this up by putting negative 3 in parentheses squared minus 2 times a negative 3, again in parentheses, plus 5. Okay? Let's go over each part carefully. Again, first we have to do the exponents. So we get negative 3 squared, which is negative 3 times negative 3, which is positive 9. Put a negative out there since that negative comes from down here. We have negative 2 times negative 3, so that's plus 6. And finally, plus 5. So in total, that's correct, Fernando. The answer is indeed 2. Great. Nice. Okay. Any questions about that? No? Okay. That's perfectly fine. Okay. So hopefully that made it a little bit more clear about what you'll need to do for those type of problems there. All right? Okay, let's go back to the Word document here, as we have some more important notes to make. Okay, so the next thing we'll talk about here is how to determine if a graph is a function. Okay, so how do we determine if a graph is a function? Okay, now we need to talk about a couple things here, and actually one thing I need to talk about is turning on the fan. Hang on. That stuff there. It's like walking a bum all over the place. All right, there we go. All right. Okay, so going back to what we're talking about here, how do we determine if a graph is a function? Well, the first thing that we need to do is, although we've talked about the notation of a function, we actually haven't defined a function. Exactly what is a function? It looks like, it comes out of nowhere. So, like Randy Orton. All right, so I love that joke. Anyway, so what exactly is a function? Well, here's how functions essentially work. Imagine, if you will, we had two boxes. All right, and we'll make one box here be all the boxes for x. Okay, and we'll make all these boxes here, they'll have another box here. This box is full of y values here. So we could have some numbers in the x box. We could have 1 and 2 and 3, maybe 2 and 3 and 4 could be in the y box. Okay, now what a function will allow us to do here is to go ahead and we can draw an arrow from one number in x to one number in y. So we're going to go ahead and do that here. So there's our first arrow, and then let's say 2 goes to 4 for whatever reason. Okay, there's a second arrow, and that can work. So this would be a function, okay? Let me put that as yes, a function. Or actually, I should probably do that. Okay. All right, but now if I drew another picture here, all right, so let's go back here. Let's say I drew another picture. So I have the same x and y here. So let's, this will be where a majority of our examples are. So the same 1, 2, 3, 4 sort of setup. Now what I could do here is I could draw 1 to 3 and 2 to 3. This is okay too. So I could have 1 going to 3, 2 going to 3. This is still a yes, okay? This is a yes, a function. This is perfectly fine. All right? So this is going to be yes. Now, where do we get a no? What's defined as a no? Like, what's no a function? So not a function, I should say. So here's a situation where we could end up with a no situation. So that is if we end up in this situation where 1 goes to 3 and 1 goes to 4. 2 can go wherever it wants. 2 can, well, just leave 2 alone. That's fine. That's correct, Fernando. That's right. So that's essentially why I wanted to highlight these pictures here. That way you can see, like, at least from a pictorial representation, about what is a function and what is not a function just on the base definition alone. Now, of course, let's formalize that definition based on these pictures that we see here. So a function, well, let's at least talk about that. So a function is a relation in which one x value goes to exactly one y value. Now, one thing that's important about this definition is that if you saw in the second picture here, everything can go to one number in y's. That's fine. You know, you could have 1 go to 3, 2 go to 3, 3 go to 3, whatever. Or, you know, it could literally be any of that. That could all go to one number here in y. That's fine. But I can't have it where I can have multiple y's associated with one x. So I can't go in reverse necessarily. So that is important to know in regards to the definition of a function here. Now, how is this important to answering our question about how to determine if a graph is a function? Well, using this definition here, we're going to conduct a certain test. That's going to be called the vertical line test. So the vertical line test is going to use the premise of what a function is and be able to kind of say, okay, we can eliminate that because of this definition. So how does it work? It's fairly simple. So all we're going to do here is, again, draw a vertical line anywhere on the graph. If it hits 2 or more points on the graph, then it is not a function. Okay. All right. So if we draw a vertical line like this and we say, all right, well, how many, does it hit more than 1 point? Is it 2 points or more? Well, then too bad, so sad. That's not a function at the end of the day. Okay. All right. Good. Okay. So all I'm going to do here is simply go ahead and we'll go ahead and look at some examples here. Okay, let's do that. Oops. All right. So let's look at this first example here. How about, I'm just going to draw some functions. You guys tell me yes or no really quick, okay? Yes, a function, no, not a function. How about this? This line, yes, or yes, a function, or no, not a function. Yes, okay, good. The answer is yes, all right? So we draw that vertical line there. It only hits 1 point. That's fine. Let's look at the next one. How about this? How about a circle like so? What about this circle here? What do you think? Sam, Julio, what do you guys think? Oh, Neon's back. There you go. Hey, Neon. Nah, that's okay. No, okay, good. Look, I know I ask you guys a lot of questions, but it's a matter of participating, even in an online session. It's easy for me to answer the questions, but it's about your guys' learning. So the answer is no. As you can see here, we have 2 or more points here. So let's try another here. How about this? I understand. No. Remember, vertical line. Does that hit 2 points? Let's say if this is a regular parabola. Maybe my drawing is pretty bad, so. What if it was kind of like that? All right, yes. All right, so I draw a vertical line here. I'm only going to hit 1 point at the end of the day, regardless of where I draw that vertical line. All right, let's try one more. How about this? No, that's correct. Good. Nicely done. All right, so 2 points here. The answer is no. Good. All right. So that's how we can determine whether or not graphs are functions of some variety. Now, let's talk about what we're going to be doing here next. Right, I want to do a problem here from the book. So the reason why this problem here in the book will set us up for a lot of different other types of applications we may see later. So this is one of those that, yeah, does have definite relevance. Okay, so the one I'm going to be doing here is going to be number 77 down here. I'll make that a tad bit bigger. Okay. So let's go ahead and read this off here for number 77, and then we'll go ahead and take a look on how we can interpret this problem here together. Okay, so the wage gap is used to compare the status of women's earnings relative to men's. The wage gap is expressed as a percent and is calculated by dividing the median or middlemost annual earnings for women by the median annual earnings for men. The bar graph shows the selected wage gap for selected years from 1980 through 2010. All right, so they give us a function here. All right, so they give us a function here. They say g of x is equal to this function right here. So it's already modeled and ready to go. Now let's read the rest of this. This models the wage gap as a percent x years after 1980. The graph function g is shown to the right of the actual data. All right, I'm going to use this information. So here is the here's the graph. Okay, now let's talk about that very first one in number 77. It says find and interpret g of 30. Okay, now I want to talk about g of 30 and what that represents. Okay, now the one thing that you have to be careful about in these word problems is context. You say, okay, what is g of 30? What does that mean? What exactly does that mean? Well, what does 30 in this context of this problem? If you read this carefully, what does 30 actually mean in this problem? 30 just seems like a random number, but it definitely does have a meaning here. What is that meaning in this case? What do you think? What does the 30 mean here? Here's a hint. Here's a hint for you. If you're not sure what the 30 means here in this problem, I want you to read this full sentence again. Just right here. Read that full sentence and then it will start to make a little bit more sense. What do you think, guys? Okay. All right. If you're not sure, just say you're not sure. That's fine. That's what we're here to do. So just let me know if you're not sure, or again, if you have a guess, just take a guess. That's fine. Not sure. That's fine. I put the question right up there, Fernando. What does the 30 mean in this word problem here? You plug it in for x. That's right, but what does it actually mean in the context of the problem? That's kind of the important point here. You do that, yes. Like, that's not the problem here that I'm really kind of asking, is like saying, all right, the 30 does have a meaning to it, because a lot of problems that we'll see here for applications is going to rely on the context of the problem here. So 30 has a meaning to it. And that's really kind of the important point that we want to do, because most of the time we just say, I said, okay, I give you this random number, and it's like, okay, you just plug it in and then you just see what you get. But that's not always how it works out. Now, I want you guys to take a look here very carefully. Read this very carefully. So we have this function here. That's fine. This models the wage gap. Okay, whatever. This says here specifically X years after 1980. All right, this right here is the biggest part of the problem. The context of what X is X years after 1980. So that means that 30 in this particular instance. So let's go to our guy here. That means that 30 here means that's 30 years after 1980. Okay, so this means 30 years after 1980, which means that that actually reflects the year 2010. Okay, so this is actually really important. Okay, this is why the context matters, because if we need to compare two values here, the actual 2010 value and this model 2010 value, well, then we can compare and see if the model fits it really well or not. That's kind of like what I'm going for here in this case. So plugging and chugging the numbers here, honestly not too hard, but in reality, which number would you compare it with? Well, that's where the context comes in and really helps out. Now, if we do plug this in, let's see what we get. Okay. So what is this going to be? 81? Yeah, 81. All right. Okay. So here we get 81, all right, as g of 30 and the actual calculation. Okay, so let's take a look at B here. B says, does g of 30 overestimate or underestimate the actual data? Well, in this case, it underestimates by 2%. So under by 2%. Okay, so that part is not too hard, but once you understand that, yeah, 30 years after 1980 is 2010, yeah, that's kind of a big deal here in this case. So context, very important. Please be very careful in regards to that. Okay. Any questions? No? Okay. That's perfectly fine. Okay. All right. Next. Let's talk about what we're doing here next. All right. So we're going to get into the next section here. Okay. So let's talk about that. Next section isn't too hard. This part, I think, was probably even easier than the first one. We just pretty much talked about a lot of it. So this next section here talks about linear functions and their graphs. We're just going to go over this. It's not very hard. We're just going to talk about a couple of things here, certainly, and we'll see how things get. So it's not too hard. Let's see. Let me check one thing though. Okay, that's fine. All right. Okay, so what's a linear function look like here? Well, you probably heard it before, and you probably said it again. Y equals mx plus b, that's your winner. That's what the linear function looks like here. Or again, f of x equals mx plus b. You know, you can say the same thing. In any case, you have, let's say, y is equal to, again, 3x plus 7. All right, there's a linear function of some type. Remember, f of x is the same as y, so it doesn't really matter. But you get the gist. F of x is equal to 2x minus 9. Yay. All right. So not a whole lot going on in terms of like how it looks, but what we want to do here is, of course, we want to graph these. We want to go ahead and use them in applications and whatnot. So we're going to see how we can find said things. It's really not too bad. Now we got to talk about at least some properties here first and foremost. So let's talk about properties of linear functions. So there are only a couple of properties here, so let's talk about those at the very least. Okay. So the first property here is basically talking about horizontal lines. So let's say if we have a horizontal graph, okay, so meaning the graph is going to look like this. Graph looks like this. It's got a horizontal line somewhere here or whatever. Okay, so the question is, how do we look at that particular problem specifically? Well, what we look at here specifically is we see that if all horizontal lines are of the all horizontal lines are of the form, I should say, y is equal to a, where again a is any number, and the line has a slope. Remember, slope here is m. We'll talk about that, of course. The line has a slope of 0. So again, in this case here, m is equal to 0. That's the slope of all horizontal lines. So again, just pointing that out there. All right, so that part there, not so bad. Now, the reason why the slope here is 0, imagine if you put like a little ball on the perfectly flat level plane, that ball actually would not move. So because of that fact, there literally is no slope on a perfectly level plane. Now, how about vertical lines? Let's talk about that. All vertical lines are of the form x is equal to a. Again, a is any number. All right. And the line has an undefined slope. Okay, so again, M is undefined. Now, why does this happen here? Why is the slope not 0 like it was in the other case? Well, if you have a vertical line here specifically, so let's say here's a vertical line. If you put a ball on a cliff face, for example, just a steep cliff face that has no angle, it's just perfectly level, then that ball can pretty much go anywhere it wants. Gravity's gonna take it. It could bounce off the side. It could do whatever it wants. So there's actually no defined slope there. If it was rolling down a hill, very steep hill, sure, but not a bald cliff face at a 90-degree angle. That's not how it's going to work. Okay, so we have that. Okay. All right. So let's take a look here at let's take a good look here at how we can graph some of these. Okay. We'll talk about how we can find the slope of this as well. So let's do that. Oh yes, I'm sorry. I forgot you guys. I apologize. Did you guys want to take a break for a little bit, or do you guys want to take a 5-10 minute break? I know there are only 3 of you, but we've been going at it for a while, so would you guys like a break? Break? Okay. Okay. So yeah, that's okay. No, I listen to you guys. It's very important. So let's take a 5-10 minute break. All right, and we'll come back at 2:30. Okay. So come back at 2:30. All right. So let's take a small little break here. Okay. I'll put myself on mute here. Hello again. Okay. All right. We'll take another minute or two. Should be okay. I'm a little lost right now. Okay. All right. Okay. Yeah. How many more notes will we take today? Uh, uh, more? Yes? The answer was yes. Okay. That's all you're getting. The answer being yes. Please no. Ah, come on now. All right. Okay. Let's talk about lines. All right. Back to work. Back to work. All right. So what we need to do is we need to talk about a couple of things here. First of all, let's talk about lines. All right. So we're going to talk about, first of all, finding, let's talk about that. Finding the slope between 2 points. So if we want to find the slope between 2 points, what we're going to do here first is we are going to, let's see here. We want to find the slope here. So we have a formula that goes with this. So what am I doing? So the slope here, or m for slope, little m, this is going to equal specifically this. So it's going to equal what we like to call rise over run. If I can spell today, let me know. And so what's that going to be? That's going to be this. Y2 minus Y1 over X2 minus X1. Okay. So this is the this is what we have here. Okay. Alrighty. Good beans and rice. Okay. So these are the slope between 2 points. Now, one thing I do want to point out, what's the key to this? One of the keys to actually figuring this out, and just to make things your life a lot easier, the key is to label both points. So for example here, we are going to have 2 points here. I'm going to label, say, the first point, whatever the numbers are, it doesn't matter, of x1 comma y1. And I'm going to label the other one as x2 comma y2. Okay. So that's basically how I label both points. So I know exactly where I'm going to plop those numbers into the formula. So if I'm given the 2 points there, then that's cool. I know I just labeled them. I just like I'll write a little bit of a thing above that, and then I'll call it good. So let's take a look at an example and see how we can find the slope between 2 points. Okay, so let's pick -2 comma 4 and -1 comma -1. Okay, so what I'd do here, if I were to write this out on a sheet of paper or whatever, is I would write this as x1, and then the next one here would be y1. And I'll tab over here. This would be x2, and then this guy would be y2. So now I know what each number goes in. And remember, parentheses here are very important. Okay? So parentheses here are incredibly important, and we have to be able to put those in correctly. So let's take a look on how this looks like with some parentheses and junk. All right. So here we have y2 minus y1, or rise over run. So we have -1, put that in parentheses, minus y1, which is 4, over x2, which is -1, minus x1, which is -2. Now you can see this is why we put parentheses. You can clearly see that we're going to have some sign changes that definitely occur here. So we have -1 minus 4, which is -5. But here we have -1 minus -2. Well, minus -2 is a plus, so this becomes +2. So this is going to be 1. So our final answer here, our slope of our line here, is going to be -5. And that's it. Okay, just as simple as that. Okay, any questions about that so far? Hopefully that isn't too bad. Okay, let me do this real quick. Okay. I mean, okay, whatever. Okay. No. Okay, good. Okay. Okay, next. Let's look at the next one here. Okay, let's look at the next one. Where is it? Let's try this. All right, let's have you guys try this out. I think this will be a good idea. Let's have you guys try this out. So I'll pick 2 points here, -3, 5, and -4, 2. So you guys try really quick. Can you tell me what the slope of this line is going to be? I'll give you guys a minute to do that. All right. Good spins. Okay. Let's see. what did you get here? -3 over -1, or 3. Okay. Let's take a look here to see if that's what we get. All right. So again, label your x1, y1. All right. And label your x2, y2. All right. All right. So if we do that out really quick, then we're going to get m here is equal to y2, which is 2, minus y1, which is 5, over x2, which is -4, minus x1, which is -3. So here we get -3 over -1, since this is plus. And that's correct. The answer is 3. So our slope here is 3. Nice. Great job, everybody. All right, any questions about that? Okay, now, right. We'll talk about that too. Yeah, sure. Let's try 2 more points here, okay? How about 3 comma, I'm just gonna make this up here. So 3 comma -1, and let's see here, 4 comma -7. All right, Julio, there we go. Can you tell me what you would get there for your slope with between those 2 points? Again, with this formula that we have here. Okay. What would we get there? -6, okay. Let's check it out. So here we have our 2 values. We have x1, y1, x2, y2. Again, if you've labeled them right, then this is what you should have once again. Okay, so having that there, we have, let's see. Okay, m here is going to be, let's see, y2, so that's -7, minus y1, which is -1, over x2, which is 4, minus x1, which is 3. So -7 minus -1, -6, over 1. So that's correct. Very nice, Julio. -6 is the correct answer. All right, cool. Okay, so far so good. Okay, any questions about that? How are you guys feeling so far? Okay? Good now? Okay, good. Okay. All right, so next, we're going to talk about another concept here, and then we're going to put these two and two together here. So we're going to talk about the next concept we'll talk about here are X and Y intercepts. Now, X and Y intercepts are not too bad. They're pretty easy, but let's talk about each one here. All right, so what is an X-intercept here, just specifically? So an X-intercept is the point where the graph hits the X-axis. Now, there are a couple of important things regarding the X-intercept. So to find the X-intercept, what we're going to do first is you're going to set y is equal to 0 and solve for x. Okay, so set y is equal to 0 and solve for x. So this is actually one of the key things there. Set y is equal to 0 and solve for x. Yeah, I probably should do that too. All right. Now, there is always going to be of the form. So the form that they're always in is going to be x, whatever x is, comma, 0. So 5, 0, 3, 0, whatever that x value is, comma, 0. Now, as for the y-intercept, that's even easier than the x-intercept, as there's only one of them typically. Again, the point where the graph hits the y-axis. All right, so to find the y-intercept, all right, all you're going to do is you're going to set x is equal to 0, all right, and solve for y. The form that it's always in is going to be 0, comma, y. Okay, so that is the x and y intercept here. Because some of the questions, what they'll ask you is, they'll ask you to find this x and y intercept, and they'll say, okay, well, how exactly do you do that? Well, that's exactly how you manage to do that at the end of the day. All right, so let's take a look here on how we can go ahead and graph some of these, or not graph. Let's go ahead and find out how we can find some of these equations, identify the slope and y-intercept, and use the slope and y-intercept to graph this and stuff. So we'll do all that. So let's see. I want to do a specific one here. Okay. All right, that's fine. So I'm going to do a specific problem here because there's a lot going on in this problem, and I want to be sure that at least you understand some of the nuances behind what we're doing here. So I'm going to do this one here. 7x plus 2y equals 14. Okay, so we're going to go ahead and do this problem here. 7x plus 2y is equal to 14. Okay, so we want to do three things in this problem. Okay, so the first one here is we're going to solve for y to put into slope-intercept form. All right. Second is to identify the slope and y-intercept. Okay. And then we're going to graph it. Okay. So let's talk about how we can go ahead and do that here in a problem like this. Okay. All righty. Let's do it. Okay. Okay, so first things first here. Where is it here? Okay, right. Okay, so first things first here. Let's go ahead and write this down. Now we want to be able to solve for y. That's the point of the problem here. So if we're going to be able to solve for y, we want to be able to, again, move everything over to one side. So we're going to subtract by 7x on both sides first. Okay. So right now we have 2y equals 14 minus 7x. Okay. Now, here's the question for you guys. What should I do next? What do you think is a good idea? What should I do next here? Divide by 2. Okay, now where am I dividing by 2? Fernando. That's correct. But where are we dividing by 2? Okay, very good. So that's right. So if we're dividing by 2 here, we're dividing by 2 everywhere. Okay? So we divide everything by 2. So that's absolutely correct. Okay? So we divide by 2, divide by 2, divide by 2. It said, okay, here you go. We got ourselves a winner. Let's take a look. So we got y is equal to, this cancels out, 14 divided by 2, which is 7, minus 7 over 2x. All right? Okay, so here's the question here. The question first and foremost is, well, now that we've solved for y, that's part A. Well, part B says, all right, well, if this is it, well, what's the slope of this particular line? We said it needs to find the slope and the y-intercept. What's the slope for this particular line? -7/2. Okay, very good. So I want to point out one thing here, all right? Sorry, for some reason I didn't see that fast enough. All right. So one thing I want to point out here specifically is that what we have here is that I want to point this out because a lot of people make the mistake here. The note, the number next to x is always the slope. Okay. So the number next to x is always the slope. All right. Now, the y-intercept basically just means I plug in 0 in for x, and then I'm going to get back out our y-intercept here is going to be the point 0, comma 7. Again, if you plug in 0 into this equation, then you'll get 7 back out. Okay, so that's our y-intercept right there. Okay, now let's talk about the graphing part here. So I'm going to rewrite the equation here. So just -7/2 x plus 7. Okay. Now let's say we are given this equation here. So if we're given this equation here, and we want to go ahead and find out how the graph is going to look like at the end of the day, there are several ways of which to do it. Let's talk about one of those ways that certainly can be helpful for problems that look like this. Now, as I mentioned here before, to graph, we make an XY chart. So let's go ahead and do that here. Let's make a simple XY chart. And we're going to plug in some numbers, and we're going to see what we get here with all these numbers here. So, all right. So let's start off with a number. What's a good number to start with? What's a good number to start with? What should I start with here? What do you think is easy? What's an easy number to start with, everybody? What number can we start with for 0? We start with 0? You guys there? Help me out here, guys. All right. Well, if we plug in 0, we get 7. That part's easy. So what's another good number to go with here? One, okay. Two, okay. So let's 1, 2, 3. Well, let me point out something here. If we chose 1, then we're going to end up with a fraction. If we chose 3, we're going to end up with a fraction. But here's the thing, Fernando, like the one thing I guess we could say is that I can choose 2. So we want to choose 2 because 2 will be able to cancel out. All right? 2 will be able to cancel out with this 2 here in the denominator. So if we plug in 2, what do we get here for our what do we get here in our case? If we plug in 2, we get -7/2 times 2. Right. Okay. So the answer here is 0. So one of the things that I recommend is that anytime you have a fraction and you want to get, it usually gets ugly with fractions, is one note is choose easy numbers to get easy answers. So you don't want fractions because it's kind of a pain to go ahead and graph. So we go ahead and choose easy numbers to get those easy answers at the end of the day. Okay. All right. So 2 and 0. So you could pick a multiple of 2 and you'll know that that cancels out. I could do the same thing, maybe not -2. Maybe -2 is kind of bad because I'll get a pretty large number. So I could pick 4, for example. 4 would be fine. And in 4's case, I'm going to end up with 7. No, I won't end up with 7. -7 is what I'll end up with. So, all right. So you can try stuff out and pretty much get it. So let's go ahead and put this on the graph. So we got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. All right, so we got 0, 7, 2, 0, 4, -7, somewhere down here. Connect these dots. All right, and then there's our graph at the end of the day. There we go. So there we used, again, you could also use the slope and y-intercept. Again, you know for a fact 0, 7 is a point. You could also use the rise over run. Again, rise over run would be like, okay, rise would be like up 7 and left 2. For example, left means negative, right means positive, up means positive, down means negative. So you can use that as well to find additional points. So it just depends. It's up to you on how you want to approach that. There is It's up to you at the end of the day. All right. Okay. Any questions about that? All right. All right. All right. So last thing here. Sorry, I know I've been going a little long here today, so I apologize. Okay, so finding the equations of lines with 2 points. Let's talk about this here as it is related to an application problem in the book. So we're going to go ahead and do that right now. So I'm going to go to this one. Okay, so let's go to 437. All right, so it talks about here, it has like average yearly earnings in the US by gender and age. Okay, so here's the yearly earnings for ages 22, 52. Okay, so between men and women. All right, that's all well and good. So you can see some points there for each one here. Okay, 0, 22, 30, 66, 0, 19, 30, 41. All right, in any case, I just want to use one of these parts here to highlight our example. It says use 2 points for the men shown by the blue voice balloons to find the function that the model averages after age 22. So here are the 2 points we're given. We're given 0, 22 and 30, 66. Okay, so let's go ahead and do that right now. All right, so we're going to find the equation of that line. All right. Okay, so in order for us to find this, we're going to first step 1. So step 1 is to find the slope. That's okay. This is always on replay too, Julio. So if you need to refresh, then hit F5, okay, in the future. That's all right. Okay, so first we're going to find the slope. Again, we can label this as x1, y1 and x2, y2. Okay, so here we're going to use our rise over run. So m here is going to be y2, 66, minus y1, which is 22, over 30, x2, minus x1, which is 0. So here we're going to get 44 over 30, 44. Okay. And so if we do put that as a decimal there, or as a fraction, we could have 22 over 15, or let's see what that is as a decimal. Okay, so 1.47 is what we're going to get here. All right. So this is our slope here, approximated at 1.47. Okay. Now, what we can do here next is we need to find the y-intercept. So in order for us to find the y-intercept, because we have 2 parts of the pieces. We have the slope here, and we also have b. So there's 2 ways to do it. I'm going to show you another way. Typically, I do it a different way, but you know what? I don't want to make things more confusing than they need to be. So I'll try it this way so it's a little bit more piecemeal. All right. So step 2, use a point and y equals mx plus b to find b. So what exactly does that mean? Well, I'm going to take one of these points. Let's say I take this first point here of 0, 22. So I have y equals mx plus b. Now I already know what m is, and I know what x is, and I know what y is. M is going to be our 1.47. All right. Our x here is going to be 0. This is our x value from our point. And our y here is 22. And then we have plus b. And all we have to do is just simply do a little bit of algebra. So what we get here is we find b. B here is equal to 22. So what that means is that at the end of the day, our final equation here is y is equal to 1.47 x plus 22. So we put the two pieces together at the end of the day. Okay. Any questions about that? And that's how we do that problem. Hey! No? Okay. So that is pretty much the end of section 7.2. There's a lot of tidbit material, but you know, it's not too hard with lines and stuff. Just takes a little bit of practice. Now that you guys are aware about the test and stuff, I'll be posting up something on Blackboard eventually today, and then I'll be posting up the test here as well once I get that finalized. If not in a couple hours, then certainly by tonight at some point is what the story will be. Okay? All right. The test? The test is posted on my math lab just as it usually is. Yeah, it's on my math lab. So you'll see it just like you did from before. So, yeah. All right? Everybody okay? Okay. So, you'll see that later tonight, but we will see you guys in a couple of days, okay? I want to thank you all again for coming on out once again. All right? We're going to continue on with chapter 7 for next time. Again, if you have any more questions, please let me know. All right? You guys have yourself a great one. All right? And we will see you again in 48 hours. All right. Have a good one, everybody. Take care of yourselves, and we'll see you then. All right.